I wish we were slowing down, but we're not. Train's going to keep going full speed ahead. So first vocabulary term. Just so you guys know up here, this is circle O. Everyone, this is circle O at the top of your notes here for day 2. Circle O. What's that tell me about O? 11. What's that tell me about O?
The O is the center.
There you go. O is the center. Here is a new angle inside the circle called a central angle. All right, central angle. Only if the vertex is the center, I call it a central angle. If I draw an angle like this, is this vertex the center? It's not called a central angle. This angle right here, is the vertex the center? It's not called a central angle. It's something different. Do you see what I mean here? The center has to be the vertex. So here, angle AOB is a central angle. Okay, angle AOB is a central angle. It's got to be the center of the circle where the vertex is. All right. So that's a central angle. I should have went over this yesterday and I totally forgot what an arc is. An arc, that's a piece of the circle, like from right there to right there. From right there to right there. That's a part of the circle. Okay. You guys know how many degrees are in a full circle? 360? Okay. Keep that in the back of your mind here. 360. All right. So first thing, symbol for arc. Symbol. There's a symbol. How do you read that? What's that? How do you read that? No, not line. No. How do I read that? Segment. Line segment AB. How do I read this? Line AB. Oh, little challenge from way back in the day. How about that bad boy? Nice. Ray AB. So how do I make arc AB? Make an arc symbol. Little arc symbol. With underneath AB. Now, I got a question. I don't know about you guys. Which arc B are you talking about? Which arc AB are you talking about? You talking about this small one here? Or couldn't it mean go in the other direction, right? Everyone agrees? All right. When I say arc AB, I'm talking about right from A to B, no other points in between. What if I wanted to talk about this arc right here? I'd call it something different. I'd call it arc. How do you think I would name that one instead? Yeah, A to C to B. So I'd use 3 letters instead. All right, notice the difference. Okay, so just go follow the order of the letters, please. Follow the order of the letters. It's the best thing you can do. How many degrees in an arc? How many degrees in a circle? 360. So what I'm going to show you right now is out of 360, how can I figure out how many degrees that arc is? Because it's not 360, it's smaller. So how can I figure out? The measure of an arc, which will be so many degrees. So I'm looking for how many degrees out of 360 that is. It's always equal to its measure of the central angle. I'll show you what I mean after we write it down here. Welcome to your first circle fact, too. Calvin, real quick, how many degrees does this angle look like it is? What do you think?
40.
40? Sure. So let's say angle AOB is 40 degrees. Guess what the measure of arc AB also is? 40 degrees out of 360. That's what I mean by this theorem. Whatever the central angle is, it's the same as the arc measure. All good? Not too bad. Whatever the central angle measures, that's what its arc measures. All right, 3 special types of arcs I need you to worry about. Maybe some of you have heard this. Semicircle? Half the circle, so how many degrees then? 180 degrees, yep. Semicircle. Half an arc, half a circle. All right, what if I want something more than half the circle, more than 180 degrees? I call it a major arc. Major arc is something bigger than a semicircle, so more than 180. Anything smaller than a semicircle, I call a minor arc. Okay, so major is anything bigger than 180. Minor is anything smaller than 180. All right, now I'm going to turn it over to you guys. I have 3 diagrams up here. In the first diagram, I want somebody to name an arc that's a semicircle. This arc blank, blank arc, arc blank is a semicircle. Name an arc up here that's a semicircle. And you could assume P is the center. 19, name a semicircle up here. TS, okay. TS, arc TS is a semicircle. Good. Could Scott have given me another one? Now, by the way, he said TS, so I know he's talking about this bad boy right here, T to S, and not the other one. What else could I have said? T, RS. Yep. All right, next one. Give me a minor arc on the next diagram. Arc blank is a minor arc. Minor, smaller than 180, smaller than a semicircle. Give me the name of a minor arc up here. 4. Arc RS. I like it. Anybody have another one in mind that you're maybe going to tell me if your number came up? What else could I have said? RS or RT, TR? Yep. Mm-hmm. And then here, give me a major arc. So this arc is a major arc. Give me a name an arc that would be considered more than 180. 11. RTS, I like it. You could have said RST as well. Yep. All right, all good on the types of arcs. All right, let's use this theorem a little bit more, how to find the measure of an arc. Let's use this a little more. I'll do the first couple, and then you're on your own. You can work with people around you or just by yourself. Find the measure of each arc in circle C. So C must be the center, right? So arc AE, everyone find arc AE first. This is your first time doing this. Arc AE is how many degrees? That's what I need to find. Well, everyone see a 90-degree angle here. What's the measure of arc? What's the measure of angle ACE then? ACE. 16, measure of angle ACE. Also 90. And since that central angle is 90, so is the arc measure. AE is also 90. See how we got there? All right, ED now. ED. How do I find ED? Well, everyone look at the 130. What's the angle next to 130? Angle next to 135? 50. They're supplementary. So if that central angle's 50, so is arc ED. You guys have 3, 4, 5, and 6 on your own or with anybody around you. Go ahead. Ready to roll? Number 3, DBA. D to B to A. What do you got for me? 9, DBA. We got a 9 today or no? Going? Going. No 9. All right. How about a 7? DBA. 140? DBA. That's a 130 and a 90, isn't it?
Oh,
D to B to A, right? 220. Okay. Number 4. AED. 15. 140. ABD. Hopefully this is the same answer I got before. 7. 220. Right? Same arcs, everyone. Same arcs. And then how about 6, BD? 12. $130. All right, any issues? Central angle always equal to its arc measure. How about these here? Percents. Find the measure of arc AB. But I don't know the angle though now. But I do know it's 20% of the whole thing. right? It's 20% of the whole thing. Let me say that one more time. 20% of the whole thing. What's whole thing there for me? 20% of 360. Correct. It's 20% of 360. So if you remember from your good old, I don't even know when they teach that, what, elementary school days? 360, how to find 20% of that, multiply it by 0.20. So arc AB ends up being 72, right? 72 degrees. And then go ahead for CD, but now it's going to be 18%. All right, anything here before I get into the second half of today? That's how to find the measure in degrees. How many degrees are in an arc? Now what I want to do with you is, hey, how long is the arc now? How long is it? How many inches, centimeters, millimeters? How long is an arc? We know how to find the measure of it in degrees. Now how long is it? You have circumference formula. Now I'm going to show you a second formula for this unit. One of many I'll give you. So how to find the length. Everyone understand what I mean, the differences now. Measure was how many degrees are in the arc. Length is how long is the darn thing. How long is it? So how can I find how long the arc is? Ready for this formula? It's not that bad. Measure of the arc, which we just spent 10 minutes doing. Measure of the arc. So you'll put degrees there, right? That's what we just found, a whole bunch of them. Measure of the arc over 360, the amount of total degrees. And we're going to multiply that fraction by something that should look pretty darn familiar. What's that? Pi d. Yeah, times circumference. All right, so the measure of the arc over 360 times its circumference. That's how we're going to find the length. All right, ready? Leave your answer in terms of pi. So what am I going to see in my answer now? 6. What am I going to see in my answer? No 6. 19. What am I going to see in my answer? A pi. Meaning, don't touch that button on your calculator. Slip it into the answer. Multiply everything else. Ready? Arc AB. The length of arc AB. First, I start with the measure. We spent 10 minutes here, right? What's the measure? How many degrees in arc AB? 6. 8. How many degrees in arc AB? 90, because that's the central angle, right? What we learned today. 90 over 360 times pi times diameter, that's already given, 24. Take a look if you're confused. Leave your answer in terms of pi. Whoop! That pi slips into my answer, and now I'm just doing 90 over 360 times 24 in my calculator. That's it. Don't put the pi there. It's in my answer already. 90 over 360 times 24. $10 when you're ready. What pi am I looking at here?
6 pi.
6 pi, and then everyone don't forget about your units here, inches. If you want to actually see how long the arc is, do 6 times pi, and that's how many inches that arc is. Anything you want to ask before it starts getting a little difficult? All right, number 2, follow the order of the letters. C, D, E. That's the arc I want to find how long is. C to D to E. All right, be careful here when you answer my question. What is the measure of that arc? CDE. What is the measure of CDE? Come on. 10?
320.
Thank you. 320. Where did Josh explain to your classmates where, because I see 40 and so do your classmates, where'd 320 come from?
I took 360 minus 40 because it's the larger thing.
Got it. Okay, it's not 40, it's the other arc, 320. Over 360 times pi. What's your diameter value here? 5. Diameter value? 18, double the 9. Slip the pi in your answer there, and then go ahead and multiply the rest. And what are we looking at here now? 15, what are we looking at? 16 pi centimeters. Boom. Questions? All right, one more here where you find the length, F to G to H. Follow the letters, F, G, H. All right, first thing for somebody, measure of F, G, H. 15 again. 135 degrees. You add the 45 and the 90. Good. Over 360 times pi d, diameter length here. Oh, 18. 6. Double 3. Yep. Sneak the pi in. You can leave it as a fraction or a decimal here. It doesn't bother me. Leave it as a fraction or a decimal. Either one's fine with me. Fraction or a decimal. What do you got? 18 again?
2.25.
There. Good. 2.25. Leave the pi there. Meters. All right. Any questions? All right. These last 3 problems, all you did was find the length of an arc. Now what I want to do to end class is I'll give you the length of the arc, but I want you to solve for one of these on the right side now. So solve for the angle, solve for the diameter. All right, that's what I'm going to give you the length of the arc now. And I want you to solve for something over here. And I want to see algebraically how do I do it. All right, go ahead, read through here. Find the circumference formula. Circumference formula I'm going to need. 2. Yep, pi d. What's the only value I need here for circumference? Only value I'm going to need. Diameter. So somehow in this problem, I need your help finding the diameter. Ready? 6.09. What is it? What does that 6.09 represent? 3? Length. Length, right? That's the length. I'm giving you the length now, not asking you to find it like the last 3 problems. I'm giving you the length. 6.09, the length, is equal to, help me with the rest of the formula now. Help me with the rest of the formula. The length is equal to 15, measure 50 over 360 times, finish the formula. 11? There we go. And guess what I'm solving for now? Not the length, but D. Yeah? Don't skip these tonight on the homework either. Tonight on the homework might say, solve for the measure. So you'll put an X here instead. It may say, solve for radius tonight. So you find diameter and do what? All right, you guys can do this. Don't skip them tonight. Don't skip them. All right, now the question is, what the heck is going on from here? How do I get D by itself? Well, I got to take care of this beast here first. 50 over 360. How do I move it to the other side? There's 2 ways I'll accept to move it. Zach?
I forget what it's called.
Twist the bottle cap off. What are we doing there?
You multiply it by 360 over 50.
Okay, one way is multiply both sides by the reciprocal. Yes, 360 over 50. Anybody else have a different way of moving it over? Via?
I just divided 50, 60.
So 6.09 divided by 50 over 360. Either way is going to work. So you guys decide. Divide both sides by 50 over 360, or going back to Zach's suggestion, multiply both sides by 360 over 50. Either way, fine. I'll do that with you. I think it's a decent number, right? Yeah, not that bad. 43.848. I still need D, but D's not by itself yet. What do you suggest I do with the pi? Divide by pi? I don't know if anybody's seen anything yet, but I'll talk about it at the end of the problem. Just keep going. Let's keep going. So I divide both sides by pi. And I get that. I'm just cheating. Go ahead, keep going. Not cheating, but just being lazy, I guess. There's my diameter. Go back, plug it back in, find the circumference to the nearest tenth. And anybody see anything what happens when you remultiply it by pi? Right? And what do we end up getting? The circumference to the nearest tenth. That number on your calculator should look pretty familiar, huh? 3. Yeah, was it 100th or 10th here?
Oh, 10.
No, is it? I don't know. 10th, yep, so 43.8 inches. Look, we got to the final answer, which is great. We probably did a little bit more work than we needed to. I don't know if anybody saw this or not, but when we got down to this point in the formula, pi d, anybody? Is what? You knew it already. It was right here, right? Pi d is the same thing as circumference. So that was our answer anyway, right? Just showing you there. Pi d is equal to circumference. So I could have just stopped and rounded it there, but we didn't. That's fine. We just kept moving. Show your darn work tonight. Show your work. Probably get going now. You got over 10, so let's go.